Assalamualaikum and hi everyone. So kita kembali lagi for the next subtopic in our lesson, which is we are going to see how to do geometric progression. So we have already seen how to do arithmetic sequence, how to find the nth term, how to find the sum of arithmetic sequence. So apa tu arithmetic sequence? Ada common difference, okay, ada plus ada minus lah. So now we are going to see how to do geometric progression, which is also the same. Kita instead of ada common difference, kita akan ada common ratio dekat sini, okay, common ratio, and then we have the formula how to find the nth term, and we have formula to find the sum of the first n terms, and dekat sini kita ada tambahan, kita akan find sum to infinity. Okay, let's see. So geometric progression. So macam saya cakap tadi, kita ada 4 main formula lah sebenarnya. Okay. So we have the common ratio. Okay, sebelum tu kita kena tahu term-term untuk geometric progression kita. So the first term secara generalnya, first term ialah A lah. Okay, obviously kita dah tahu dah, T1 is equals to A. And then our second term is equals to AR. Our third term is equals to AR square. Okay, dan seterusnya lah. So macam mana kita nak cari common ratio kita? So kalau sebelum ni untuk common difference kita tolak, second term tolak dengan first term. So untuk geometric progression, kita akan bahagikan. Okay, so common ratio kita define dia sebagai R. So R is equals to Tn plus 1 over dengan Tn. Okay, maksudnya Tn plus 1 tu ialah term tu bahagi dengan term yang sebelumnya, ataupun kita boleh tulis T2 over dengan T1 lah dekat sini. Okay, so next, how to find the nth term, which is Tn. So the formula is Tn is equals to AR to the power of n minus 1. Okay, so A is your first term, R is your common ratio, n minus 1 to n minus 1 lah. Okay, so next, for the sum of the first n terms, we will have two formula for this. So what differentiate between these two formula? Okay, let's see. We have Sn equals to A Rn minus 1 over R minus 1, and then the other one we have Sn is equals to A 1 minus R to the power of n 1 minus R. Okay, so what's the difference between these two formula? We are going to identify either it is your common ratio is greater than 1 or less than 1. Okay, so if your common ratio is greater than 1, you have to use this formula. If your common ratio is less than 1, you have to use this formula. Okay, so macam mana nak senang ingat? Kalau greater than 1, kita tengok R mesti kat depan. Okay, Rn minus 1, R minus 1. Kalau less than 1, R mesti kat belakang. Okay, so 1 minus Rn. Okay, so sama macam arithmetic progression, it is so much better if you can memorize all this formula. Okay, okay, ada satu lagi tinggal pula, the sum to infinity. Okay, so we have sum to infinity is equals to A, which is your first term, over by 1 minus R. Okay, we are going to see more on the sum to infinity later. So now let's proceed to example 7. The question asks to find the general term. General term. So apa tu general term? Okay, general term Tn. Okay, which is basically is your nth term lah for the geometric sequence 8, 16, 32, 64. Okay, macam saya cakap, make sure when you read the question, you have to identify either the question said about geometric or arithmetic. Okay, so now if for arithmetic, the first thing you have to do is you have to take out A and D from the question. So for geometric, you have to find your A and R from the question. So we have our sequence here. So the first term is equals to R pula 8. So your common ratio R is equals to second term 16 divided by 8, which is we got 2 there. Okay, sama jugalah kalau kamu buat 64 divide by 32 pun kamu akan dapat 2 juga. Or 32 divided by 16, we are going to get 2 as well. So that is what we mean by Tn plus 1 over Tn. Okay, so the question asks for the general term. We know that how to find our Tn. So Tn is equals to AR n minus 1. So our A is 8, our R is 2. So n minus 1 je lah. Okay, reminder. Okay, important here. Please do not do this. 8 darab dengan 2 n minus 1. Okay, 8 times 2 to the power of n minus 1 is not equals to 16 minus 1. Not equal. Don't do this. Please, please, please don't do this. Okay, as my students, I hope I'm not gonna see this type of working in your solution. Okay, 8 dengan 2 tak boleh didarabkan. Okay, so what can we do is we can simplify, which is 8 is 2 to the power of 3, 2 to the power of n minus 1. Okay, so this is indices. So darab kat sini ialah darab sebenarnya. So bila darab kita boleh tambahkan power dia. So we will get 2 and 3 tolak 1 kita ada 2. Okay, so this is our nth term dalam bentuk simplify lah. So kalau dia tak suruh simplify, sebenarnya dekat sini pun dah boleh jadi jawapan kita. Okay, so important. Kenapa important pula? Important. Okay, so that is one thing. Tak boleh darab. Okay, 8 dengan 2 tu tak boleh darab. Jangan darabkan. And this one jika perlulah. Jika perlu. Okay, so let's see for question B. Find the 9th term of the geometric sequence. So first thing first, we have to find our A. So our A is 27. R is equals to 9 over 27, which is equals to 1 over 3. And 9th term, which is we are going to find our T9. So the nth term is AR n minus 1. So our A is 27. R is 1 over 3. N is 9 minus 1. So we have just press your calculator, you will get 1 over 243. Okay, please again do not multiply 27 and 1 over 3. Okay, you are not allowed to do that. Wrong. Totally wrong. Okay. Alright, so the next question we have, given the nth term of a sequence is Tn equals to 2 over 3 n minus 1. Okay, dia bagi nth term dekat kita. The question asks to show that the sequence is a geometric progression. Okay, so show. So, apa yang kita tahu tentang geometric progression? The only thing that we know about geometric progression, macam mana kita tahu soalan tu ialah geometric progression? Kita tengok yang the next term tu bahagi dengan the previous term tu kan? Betul tak? Kita akan tengok dia adalah constant dekat setiap term macam ini. Macam ni. This thing, 16 divided by 8, kita dapat 2. 32 divided by 16, kita dapat 2. 64 divided by 2, kita dapat 2. Okay. So, ada constant dekat setiap division kita dekat situ. So, we know. Okay, geometric progression dekat sini. Geometric progression, apa yang kita tahu? We know that our R is equals to Tn plus 1 over dengan Tn. The next term divided by the previous term, we will get a constant. Okay, so when the question asks to show, what are we going to find? What are we going to do is we are going to show our R or D kalau dalam arithmetic is a constant. Okay, is a constant. Itu yang kita akan buat. So let's see. The question give us n term. Tn is equals to 2 over 3 to the power of n minus 1. Okay, so we have Tn is equals to 2 over 3 to the power of n minus 1. Okay, so we have Tn. Tn ni ialah Tn yang ni. Okay, so now we are going to find Tn plus 1. So apa beza Tn plus 1? Basically kita just plus, buat n plus 1 dekat sini lah. So Tn plus 1 is equals to 2 over 3. So dekat n ni kita ganti dengan, dekat n ni kita ganti dengan n plus 1. So you will get n plus 1. Okay, boleh faham ke? Okay, n yang tadi tu kita ganti dengan n plus 1. So ada minus 1 lagi kat situ. Boleh nampak? Okay. N kita ialah n plus 1 sekarang ni. So n dekat sini kita kena ganti dengan n plus 1 lah. So simplify, we will get 2 over 3 to the power of 1 minus 1. Kita ada n lah. Okay, so our Tn plus 1 is equals to 2 over 3 to the power of n. So now, as what I mentioned before, if the question asks to show that the sequence is a geometric, we have to show R is a constant. So kita tahu R kita yang ini. So we will have R equals to Tn plus 1 over Tn. So our Tn plus 1 is this thing here, 2 over 3 power n. Our Tn is this thing here, 2 over 3 n minus 1. Okay, so this is indices, 2 over 3 same base, so we can subtract the power. So kita akan dapat 2 over 3 n dekat atas tolak dengan n minus 1 yang di bawah, which is we end up with 2 over 3 n tolak n dapat kosong, negatif 1 kita akan dapat 1. Okay, so basically R kita is equals to 2 over 3, which is a constant. Okay, tahu tak constant tu apa? Any number tu constant lah. Okay, so kita buatlah conclusion. So we make our conclusion, since Tn plus 1 over Tn is a constant, the sequence is a geometric progression, GP. Okay, so mesti kena ada conclusion tu. So the same thing with arithmetic, but the difference is for arithmetic you have to show for D lah, Tn plus 1 minus Tn. Okay, so kalau soalan suruh show, kita tak boleh substitute value dekat dalam ni, tak boleh masukkan value. Masukkan value tu bukan show namanya. Okay, so that is one thing. So we continue to C2. Okay, baca soalan, tengok apa benda yang dia minta. Find the value of n where Tn is equals to 256 over 6561. Ada correction dekat sini Ini ialah 6561. Tolong betulkan. 6561. Okay. So find the value of n, which is we want to find n. We have the nth term. We have Tn equals to 256 over 6561. Okay. So what do we have here? We have our Tn. Tn is a general term, which is AR n minus 1. Okay. Which is, we actually have our Tn from here. Okay, we have our Tn from here. So we can use our nth term from the question. 2 over 3 n minus 1 is equals to 256 over 6561. Okay, so sekarang masih lagi balik semula kepada chapter 1 kita, indices ataupun index equation. Ini ialah indices. Kenapa dia indices? Sebab dia ada power of something. Okay, which is base dia lain. So apa yang kita boleh buat is we can log both sides. Okay, so we can log 2 over 3 n minus 1 equals to log 256 over 6561. Okay, and then macam biasa, the power we bring in front, n minus 1 bawa ke depan, n minus 1 log 2 over 3 equals to log 256 over 6561. And then we have n minus 1 is equals to log 256 over 6561 divided by log 2 over 3. Okay, tekan calculator dapat apa? So n minus 1 equals to 8. N is automatically equals to 9. Okay, so kalau base tak sama, we can log both sides. But actually, kalau kamu tengok betul-betul, 256 over 6561 ni sebenarnya boleh juga disamakan base dengan 2/3. Okay, or 2 over 3 n minus 1. Cuba cari 2 over 3 power berapa? Tekan Tekan calculator. Power 8 sebenarnya. Okay, 2 over 3 power 8. So we have the same base. Straight away we will have n minus 1 equals to 8, n is equals to 9. Okay, both methods are accepted. Okay, unless kalau kamu macam susah nak fikir lah 256 over 6561 tu base berapa, macam tak terfikir kan, then we are going to log both sides. Okay, alright. So the next example, last example for the nth term, we have the question said the second term of GP is 2 over 3. Okay, macam biasa, sambil baca, sambil tulis. The second term of GP is 2 over 3. The fourth term of GP is 1 over 54. Fourth term is 1 over 54. If all terms is positive, okay, if all terms are positive, apa maksud all terms are positive? Okay, contohlah, first term positive, second term positive, third term positive. Obviously kalau kita bahagikan dia, kalau kita bahagikan, kita akan dapat positive common ratio, betul tak? Kita akan dapat positive common ratio, ataupun sebenarnya kita boleh tahu yang n kita sebenarnya sentiasa positif, ataupun R kita akan jadi positif. Okay, sebab dia kata if all terms is positive, first term positive, second term positive, third term positive, and so on. Okay, so what the question one? The question one for R and the nth term. Okay, so we have to find these three things. So basically we have T2 and T4 for geometric progression. So the nth term for GP is AR n minus 1. So for this case, we will have AR n minus 1 is 1 lah, 2 minus 1 equals to 2 over 3. So this is our first equation. And then we will have AR n minus 1. So 4 minus 1, we will get 3, 1 over 54. Second equation. Okay. So now we are going to just substitute. So as you can see, we have AR from here. So kita boleh keluarkan AR kat sini, which is kat sini kalau kita keluarkan AR, dia akan jadi AR darab dengan R square. Okay, AR darab dengan R square, betul tak? So kita tulis from 2 lah. From 2, AR cube is equals to AR R square. So AR is from 1, we have 2 over 3 R square, which is this all thing is equals to 1 over 54. Okay. So we will have R square equals to 1 over 36. Okay. Square pindah sebelah mesti ada dua jawapan, which is plus minus 1 over 6. Okay, but the question said if all term is positive. So since all terms is positive, since our n greater than 0, we know that our R will always be positive. So we can conclude, therefore our R is equals to 1 over 6. Okay, so R settle. So now we want to find A. Just substitute lah dalam salah satu equation kita. So we have from 1 we have A. We know R is positive, 1 over 6 equals to 2 over 3. Then we will have our A is equals to 4. So we have our A, and the last one is we want to find the nth term. So just substitute into the formula AR minus 1. We have our Tn is equals to AR minus 1. A is 4, R is 1 over 6, and minus 1. Okay, Tn is equals to 4 times 1 over 6 to the power of n minus 1. Again, saya ingatkan jangan darab 4 dengan 1 over 6. Okay, so that is all for the nth term. We are going to continue on the sum on the next video.